Here's the last question on the practice test. This is certainly an honors level. If my instruction goes over your head, don't worry unless you are an honors student. pKa value was introduced in your buffer lab. It is defined as the minus log of the Ka. So that's the mathematical definition of this. So it kind of looks like pH, but we're not taking the log of a H plus molarity, we're taking the log of Ka. Mathematically, this means that for the aspartic acid, if pKa equals 5, that means that Ka is 10 to the minus 5. The most important thing about pKa is that it determines the balance between the protonated and deprotonated forms of any acid. In this case, we're talking about the biochemical amino acid. When pH equals pKa, the balance between protonated and deprotonated is 50-50. 50% protonated and 50% deprotonated. If pH equals pKa. So at pH 5, there'll be an equal concentration of protonated and deprotonated forms of this aspartic acid. We'll have both forms in equal molarity. Now, the question here says, what if the pH is 6? You should realize that pH 6 is getting to be a higher pH. That will tilt the equilibrium in favor of the aspartate that is deprotonated. At pH 6 will be mostly deprotonated. Just a tiny bit will be protonated. So this is the conceptual idea. If pK is 5, then pH 5 is a 50-50 mixture. pH 6 is mostly deprotonated, the high pH form. If we did pH 4, it would be mostly the low pH form. Always in equilibrium, though. Now, let's do the math. Ka is the molarity of H plus times the molarity of the deprotonated form, the RCOO minus. And on the bottom will be the associated form, RCOOH. So this black to red is the ratio of deprotonated to protonated. And if we put in the actual numbers, Ka is a number, 1 times 10 to the minus 5, because pKa is 5. H plus, the pH is 6, so H plus is 1 times 10 to the minus 6 molar. I don't have a number for this. I don't need a number for this. I'm looking for the answer as a ratio. Maybe it'll be easier to see if I kind of write the black on top of the red like that, and you can see it as a ratio. To solve the problem, to answer the question, the mathematical argument, put the green numbers together. That'll be 1 times 10 to the minus 5 on the top, 1 times 10 to the minus 6 on the bottom. I'm just doing algebra, though it is pretty ugly algebra. What's left over? RCOO minus on the top, RCOOH on the bottom. You should see that the black to red is what the question's asking for. The ratio of deprotonated to protonated is right here. So the right side is what is described in words. The left side is the 10 to 1. If you actually do the division, 1 times 10 to the minus 5 divided by 1 times 10 to the minus 6 is in fact 10. So I have proved with my colorful algebra exactly that which I was trying to prove, that the ratio of the deprotonated to the protonated, if pH is 6, is 10.